Now we're going to do an example that has 4 variables. Making a K-map for 4 variables is very similar to the 3 variable case, except now our rows will have 2 variables with every possible combination of literals, and our columns will have the other 2 variables with every possible min term you could create out of those literals for those 2 variables. And again, we're still following that principle of just one literal is changing at a time, and the wraparound effect applies to the rows as well as the columns wrapping around. And this is also an opportunity to practice starting with a K-map and then translating it into a Boolean expression. So before we play around with the K-map, we're going to translate what we have in front of us into a sum of products, or a Boolean sum of Boolean products, or our Boolean function or expression. These are just lots of different ways that you might hear the terminology. So, what do we have? Well, we have W bar, X bar, Y bar, Z. That's what this one indicates because of what row and column it's in. So our first term is W bar, X bar, Y bar, Z. So all I'm doing is I'm taking a K-map and translating it into the expression, just because our previous examples I started with the expression and then we translated that into a K-map. So continuing, we have W bar, X bar, Y, Z. W bar, X bar, Y, Z. And for no particular reason at all, I'm just going to write on the next line because it just goes nicely with my what's filled in my K-map. Okay, so W bar X, Y bar Z. W bar X, Y bar Z. W bar X, Y bar Z. W bar X, Y bar Z, plus W bar X, Y, Z. W bar X, Y, Z, plus W bar X, Y, Z bar. You might notice I fixed the bar on the Z here because it was a little too long. Looked like it was covering the Y as well. So I just wanted to eliminate that potential confusion. All right, so we have W bar X, Y, Z bar. And moving forward, we have WX, Y bar, Z bar. WX, Y bar, Z bar. Then we have WX, YZ, WX, YZ, WX, YZ bar. And then one more term in the last row, which is WX bar, YZ. WX bar, YZ. There's nothing special about the order in which I wrote these terms. You would not necessarily find these terms in this order if you were given a problem like this. I just, for convenience, translating from the K-map, I just decided to go row by row, look at the ones, figure out what min term is represented by that filled in cell in the K-map. All right, so now that we've translated it into the expression that we're trying to simplify, let's go back to our principles of using a K-map, which is we want to cover all these ones with the biggest pieces possible. And so when I was saying earlier, you can overlap, but not too much. One example of that was like if I circle this 2 by 2, for example, and then I circle this 1 by 2 or 2 by 1 here in addition to that. That's excessive because I already have all those ones covered. If you have these ones all covered, you don't need to make an entire shape out of ones that already have been covered by something else. If you make a new shape, it should be covering at least one additional one that has not already been covered. All right, so I'm going to do attempt 1 here. I'm going to do my first attempt to do my circling and getting the right bits, getting the right size pieces, covering all the ones, following those ideas that we were sharing earlier. Well, since I already started to circle it, I'll just circle this 2 by 2, since we noticed that. Next, I can circle this column of ones. And then let's see, okay, there's going to be a row here, a row of ones, a full row of ones. And it's helpful for us to remind ourselves from the previous example, what does this row mean? Again, we have every possible combination of y's and z's, which will simplify to 1, and that tells us that all we have left is w bar x. And then similarly for this pink column here, we have every possible combination of w's and x's, negated or not, being added together. That's going to simplify to 1, which means this pink column just boils down to yz. All right, so let's say now I just circle, I want to cover the rest of the ones, so maybe I do, let's say I do this 2 by 2, and then since I have this 1 left here on the left side that it's not covered, I'll just do this 2 by 1. All right, let's see what we got. All right, in the green 2 by 2, we have both possible ways of getting x, and we have both possible ways of getting y. So that means we don't have any x or any y in this min term. We just have w bar and z. W bar and z. Pink. Well, we said that's just yz. Purple. That's this row, which, as we said earlier, is w bar x. And we have 2 more. Maybe I'll just write those on the next line. We have 2 more terms. So we have this goldenrod 2 by 2, which would be what? It would be, well, let's see. We have both types of w. We have w or not w. And we have z or not z. In other words, this is just xy. So I have xy here. Plus, finally, let's see, this red over here on the left is which term? Well, We have both types of W, so no W. We have X, we have Y bar, Z bar. So we get X, Y bar, Z bar. Okay. Now, is this as simplified as we could get? Well, it's hard to tell just by looking at this. I mean, we can try and play around with properties with the remaining terms and see if we can simplify more. But that's kind of a pain to do, and that's the whole purpose of using K-maps. If you are currently suspecting that we could have done better, you are correct. It's great that we got this additional 2 by 2, but there was a different way to circle a 2 by 2 to cover all the ones with the biggest pieces. Okay, so we're gonna just compare here.